everybody. Today we are going to see what a package is and how you can create a package and modules in it. We already have seen what a library means. We have seen the standard library of Python, which includes some familiar modules like math module, statistical module, random module, and we have used the functions in it also, importing the module and then use the functions. And there are other libraries like NumPy, tkinter library, etc. Here we are going to see how we can create a package. Sometimes we call this package a library because it contains modules which can be reusable and it will be there in the Python library. Now Python has this package. You can also create package and you can create modules in the package also. Simply, a package or a library is a collection of Python modules. Package is a library which is a collection of Python module, which is having collection of Python modules. Modules like math module, etc. Math module itself is enough because it is very familiar and we have been using them mostly. Now all packages in the module has the same namespace. We said the names are stored in a particular place, or it is a group of names. So the names are stored in a particular place and package has a namespace also. Every names used in the package will be in the namespace of that package. Okay. So in your program, every name that you are using, the identifiers, functions that you are creating in your program will come under the namespace of your program. It will not be the namespace of some other program. Okay. Similarly, all packages in a module has the same namespace. No, this is actually the other way. All the modules in a package, it has to be the other way. All the modules in a package has the same namespace. Okay, that means in the standard library, we know that it is a kind of package you can imagine, or just say NumPy. NumPy, the submodules in NumPy will be in the same namespace of NumPy. Okay, that's it. Now package is similar to a directory. Now we are going to create a package. So we have to know what it look like. So package is a kind of directory, a folder that you can create in your computer. And the sub packages will be sub modules. That means the sub folders in your folder, the main folder. And the modules will be the Python files in it. So files, folders and main folder. The main folder will be kind of your package and the subfolder will be sub packages and the module is kind of file. Then package contains init file along with the modules. So what makes a package or what makes a directory a package is this particular file called init.py. This is double underscore, then init, then double underscore. There's no space, that's why .py. It's a small file. It may be empty also. You don't have to write anything in it. But if you are creating a package, you will have to create a directory, name the package, then inside it, you just have to create a Python file init.py in it. That makes the package a package. Now this is the structure of a package. That is, this is the main folder, game, and inside that you can see init file, and it contains sub packages also. Why are they become sub package? Because they also have init file in it. See, so level and image are sub packages, and there is another folder also, another subfolder also in this game package, but it is not a package, a Python package, because there is no init file here. So this one is not a Python package. Init.py in a folder indicates that it's an importable package. If you can see init.py in a folder, then you can say that this particular package is importable. You can import it. That means import image. This way you can import this particular package. First you have to take this main package also, which means import game.image. That's how you will have to refer this package. Now if init.py is not present, if it is not there, then it is not considered as a package. If there is no init.py, then it is not considered as a package. Now let us see how we can create a package. Okay, there are some steps. Now first one is to decide the basic structure like this. So the first name, the top level folder should be this. So the game is the name of it. This you have to decide. Then what should be the sub files in it? So here we have two files. One is image and the other one is level. So this hierarchy you need to decide. So these are the sub packages. This hierarchy you will have to decide first. Okay, and create the init file in it. Here also under this package you have to create an init file. Okay, and there is another folder which is sound. Another folder is here which is sound, but there is no init file in it. But here you can have this init. Here also you have the init file. In level also you have init file. So the structure you have to decide what should be the name of the main package. Should there be any sub packages? It is not necessary. This is optional. If you have to declare some packages, this way you can use. But it is not necessary that a package should contain a sub package. It is not necessary at all. Okay, but there will be modules in it. That is, py files will be there. Okay, here also you can have py files in the module, and in the main module also. That means here, if you can draw another branch, and without having a sub packages, you can have a py file, not like init file, some py, some Python program. This will become your module which contains some functions in it. Okay, so the top level package can also have some Python files or modules, and sub packages may also there. So these are modules: open.py, change.py, close.py, start.py, load.py, over.py. These are actually modules in the sub packages. Level has 3 modules in it, and here image has 3 modules in it. This is not at all a package. Then this one, s.py, another module. Okay, so a structure you have to decide: the package name, what should be the modules and sub modules in it, the package and sub packages in it. These things you have to decide. Next thing, create a directory structure with packages and sub package. Once you decide the basic structure, then you create the structure. Okay, so you have to create it by creating the folders. Now create init.py in the package and sub packages. Just create a Python file and save it in this. Now the next thing is to Next thing that you have to do is associating this with the Python installation. That means the package should be a part of the Python. How can you make that? There are some codes to do it, but in the simple way you can do it by keeping this particular package in the package directory. Okay, we call that actually this one we can see an example here. We call this side packages. Python has a particular folder called side packages in which all the packages appears supported by Python. So here you can save your package. Okay. So associate it with Python installation. Find the side packages in it in the Python. That means you have to find that folder in your system and create a folder there as the package and do the rest. Okay, this is what you have to do. Now once it has been created, and create a module inside, then you can import it using the normal import statements. So this is the actually the side package. This path we have to find out. We will see how we will be finding this path in your system. This is where we install this Python. So this side package will be in the this path. Okay, so this is the one I have created now. Fold is the name of the package I have created, and I created a empty init file also, and this is our module. This is our module. You can see that it's a Python file. Temp convert is the name I gave to it, and this will be the same name of the package. The namespace will be the same name of that package. Okay. Clear? So temp convert is the module I have created. This is a module. Okay. And I can also have other conversion programs here, conversion modules. Here this one I am going to convert temperature, degree to Fahrenheit and Fahrenheit to degree. And the same file, the same folder fold can have other conversion files also, modules also, which convert centimeter to meter, okay, kilogram to liter. So any kind of conversion modules you can create as py file. It has to be a py file. Module will be a py file, which means it is a just Python program, nothing else. Module is a Python program which is in the form of a normal file, Python file. Okay. Now we are going to see what we have written in temp convert. So this is the code. You can see it is a module. It should be written as a triple quote, the doc string, so that when you use the help, then this will appear if it is a doc string. But I used it as a normal command. You will have to write it like doc string. That means triple quote should be used here. So inside the function, you can have inside this module there will be, we have seen in the previous class, there will be doc string, and there can be variables, global variables and constants you can declare here. Variables will be there and constants will be there. Okay, and then the functions, etc. and some classes, objects. This will come, but classes and objects are not in our syllabus. We are not writing them also. So we don't have variables or constants here. In this program there is no variable or constant. We just have triple quoted. If you imagine this as a triple quote one, then it is a doc string. Doc string is there, and we have two functions. The first function is to Celsius and Fahrenheit temperature will be given, and it will convert the Fahrenheit temperature into Celsius using this formula, and the result will be returned to whoever part called this function. Okay, so temp convert.py is the module, and temp convert has two functions. One is to cell, second one is to Fahrenheit. To Fahrenheit will take a temperature in Celsius, and using a formula, the temperature will be converted into Fahrenheit measure, okay, and this calculated result will be returned to the calling program. Okay, this is it. Only two functions, very small function. This is an example, that's why I made it very small and simple. Now we created a module. You know that the module need to be called from other program. You cannot execute sqrt function by itself. No, what you have to do, you have to call it from some other part of the Python program. Okay, so this is a program. You can see that temp use is the name of the Python file, normal Python file program. Now this file imports the temp convert module. So temp convert is a module which has been stored in this package fold. Fold is the name of the package. So package name dot module name, okay, as tp. So in short, instead of writing fold dot temp convert, you will be writing tp. Okay, another name to it. We call it alias. I hope you remember. ALIAS, alias. Okay. So import fold.temp convert. We created it in somewhere else. Then what we did, we imported this file or this module as tp. Now what we are doing, we are taking a Celsius temperature and see what we did, tp dot, we are converting it into Fahrenheit, tp dot to Fahrenheit. This is the function name you can see here in the module. To far is the name of the function. We use that here. But how did we use it? Module name dot function name. This is the module name. Dot operator is used just to identify where this function has come from. And we pass this C. The Celsius temperature we received from the user is passed to this function. Now what will happen? Whenever you import a module, this module content, whatever content in this module, will be brought to the namespace of temp use. This program, whatever be in the module, it will be brought in the namespace of temp use. Okay, in the current directory file. So whenever a name is seen in this way, it will check the current directory first. Then the second one is, so this is over. We just found the Fahrenheit equivalent of the given temperature. The return value will be printed here. The return value by this function will be printed here. Okay, now the second one is, the user will be inputting a Fahrenheit temperature, and this function is called module name, that is tp dot to Celsius and the received value f. This f value is passed to the function. So it will check where this cell has come from, to cell where it is. When you import this file, temp fold convert will be part of the temp use namespace. So this is the temp use namespace. For example, whenever Python interpreter finds this kind of import, what will happen? Fold dot temp convert will be part of the namespace of temp.user. So everything in f.t, that is fold dot temp convert. This is actually a package and module. This package will be brought to the namespace of the area of names for temp use. Okay, so whenever such a name is referred in the program, it will know where to look at. Okay, TP is actually f dot t namespace is brought, which is brought to this t dot use or t temp use. Okay, and this will be checked. Okay, this will find the name in this part. Then understand what the function is and execute the function and return the value back to this namespace. Now similarly, this one, to cell namespace has already been come to this or copied to this namespace, and Python will know where to look for this function because it has already been imported here. Okay. So this is the output of the program. You just run, the file will be imported and kept in the namespace of temp user. Then whenever the name is used, it will go check in the brought file and finds the output and returns it, etc. Now Python looks for functions and module names. Where does Python look for functions and module names whenever it sees it? That means in this program, Python saw this particular function name. Where does this Python program look whenever it sees a function name? That is the question. When an import statement is found, whenever import statement is found in the Python program, the interpreter of the Python checks the current directory. The current directory. In the case of this program, the current directory is not fold. Fold is somewhere else in the state package, site package. Okay. Temp use is maybe in the D drive or in the E drive, wherever you save your Python program, which is not part of the Python package. Just a program which uses some Python packages. So the current directory will be maybe E drive or D drive, etc., wherever you save your program. That may not be where the Python package or Python software keep its files. Understood? So whenever name is called, first Python looks in the current directory where the program, the currently running program is saved. If it is not there, if it is not found there, then it checks the directory listed in the Python path. Okay. So Python path, it is very easy to find out. You will have to just execute these two codes, then you will see where the Python path is. Site path will be shown there. If not found, if it is not in the current directory, then it checks the directory listed in the Python path. Python path can be printed using the following Python code. Import sys print sys.path. All the Python files where it has been stored will be seen here. So if you have a Python program at home, you can just type these two. First you have to import sys. So sys is actually a module that you are importing, a package that you are importing, and from which you are accessing the Python path, where all the path of the Python files are kept, in which you will have to find, in the first one I showed this here. See, when I checked that, I found the site packages in it. So this is the Python file storage location, in which you have to find this site package folder. Okay, then you create your package there. This is how it works normally, in the normal case. In your system you can do this. So this is all about Python and Python files. You have seen from the examples that fold is a package. It is just like a folder or a directory in which you can create your module, which is a normal Python file, and in a package there will be in it file also. Okay, when you run the program, PyCache will be created automatically in it. So this program I saved in the C drive, user administrator and data, local programs, Python. This is the Python file coming. Now the sub package and the subfolder and the library, in the library site package. This is where I stored my fold. This is the package I have created. But the program temp use, which imports the file, is somewhere in the D. You can see the path here. It is in the D pack, just a folder. This one is just a folder. Inside D there is a folder called pack, and this is where I saved my program. But I still can access the fold.temp convert which I have created, and I can give it a new name also. Then I can use the functions in it using this syntax. Clear? So package is like a directory or a folder in it. A package can have subfolders in it, and it should be containing init file. The module that you are saving in a package are simply Python files which has functions that can be reused in some other programs. Clear? So this is all about the Python. Now here you can see some questions. This question you will have to answer